Okay, now we will discuss in detail on the problem with the dielectric material, so-called a breakdown in dielectric, or in other words, what we can also classify as the failure in the dielectric material. As what we can see here, the breakdown or the failure can be categorized into three, which are gases, and then solid and liquid, depending on the state. First, we look into the failure of the gases. Okay, obviously, gases in general are the excellent insulator. Okay, and some gases will have a different dielectric strength and capability, like as compared to air versus SF6. Obviously, SF6 is having higher dielectric strength as compared to the air. Okay. However, when dealing with the high voltage, we are talking about we cannot deny, we cannot run away from the high electric field region. Okay. When you have two different potential at a very high field, at very high voltage, obviously there will be electric field developed around the electrode, around the conductor, and this high electric field can actually transfer a certain amount of energy to the molecules of the gas particles. Okay, what actually happened is that if we go to the basic construction of atom molecule here, we have the proton, we have the nucleus, proton, and obviously the one at the orbital shell is actually the electron. Okay, once the molecule of the gas is within the high electric field region, the energy from the high electric field, can be transferred to this electron, in which the movement of the electron will become the kinetic energy, and the movement of electron will become faster and faster until to a certain extent this electron with various factors that we'll discuss later can escape from this molecule. Can escape or run away from this molecule, in which in this scenario we can classify as the breakdown or the failure of the dielectric material, in which the material will lose its stability. Initially is firm, original is in the stable conditions. Once they've got the electron by the influence of many factors, got excited, the extra energy to escape from the stable molecule, then that is what is categorized as the breakdown. Okay, you can read this the specific or detailed explanation, and this is what we call as the ionization process. For example, we have the incident radiations. We have the molecule, nucleus, and we have the electron. Once the radiation bombard the energy, hit the electron here, and then somehow the electron, the secondary electron, the electron managed to escape from this molecule. That is what we call as the ionization process. The ionization process is actually the initiation, the first step before the breakdown occurred in the dielectric material. This is ionization process is the first step for the breakdown to occur in the dielectric material. This illustration is a good example to show or to represent the ionization process as the first step for the breakdown to occur in the dielectric material. If we want to write in a proper way, ionization is the physical process of converting an atom or molecules into an ion. For a particular molecule or atom to become ion is actually either by removing the charged particles, or in this case the removing of the electron or the addition of the electron. Then if the removing of the electron, then the molecule will become positively charged, and if the electron is added to the atom, then the molecule will become negatively charged. Depends on the subtraction or addition of electron. This is a kind of the basic physics that we learned, I think, in standard 5, standard 6 in the secondary school. I do believe you all can still recall, but I don't want to go into detail on this one. It's just a matter to help you to understand how the process, or how the ionization process occurred. It's basically, as I explained before, is the removal or additional of the electron into a gas molecule. If you can read here, it is necessary that energy of the electron exceed the energy difference of the potential barrier. Within the molecule. The energy release, the energy can be the energy for the electron can be absorbed from radiations, from the collisions, a collision between the molecules. Then the collision between the molecules sometimes will absorb the energy from the kinetic energy, and then it will gain more and more energy, which enable the electron to have enough energy to manage to escape from the molecules. And other than that, that can be from the electric field. The electric field will just give the additional energy to the electron, either for to escape from the atom, or to escape from the atom, or to be added to the atom. Let's come to this. The amount of energy required is called the ionization energy. This is the energy that is required for a molecule to become an ionized, or maybe to become a charged particle. Either negative or positive. In this case, for example, if you look carefully here, we classify as W energy, I is ionization, potential. With the help of potential, potential, obviously potential different, in which the electron been accelerated into the field, electric field, in order to acquire equal to the ionization energy. In this case, we generally define the ionization energy as electron volt. Electron volt, or also known as ionization potential. Electron volt. So electron is because the process ionization involve the formation of charged particle, then that's why, which involve the electron, and then volt referring to the potential difference. That's why we refer to the electron volt, known as ionization potential. So 1 electron volt, is equivalent to the charge of electron, charge of electron times to the voltage applied, or the potential difference between within the material. For example, in this case, 1 electron volt is equivalent to the charged particles, charge of an electron, which is in this case 1.6 times 10 to the minus 19 coulomb. Charge. The unit of charge is coulomb, times 1. So 1 electron volt is equivalent to 1.6 times 10 to the power of 19 joule. The energy of 1 electron volt is actually 1.6 times 10 to the power of 19 joule. This is the energy that is required for the value of 1 electron volt. Okay. Okay. Electron volt. Okay. By looking at this one, by looking at the periodic table. Okay. Periodic table. Okay, we have element 1 to 18. Okay, say here electron volt. Okay, electron volt is low for the first element of each period. Okay, increase to the maximum for the last element. Why electron volt is low at the first and high at the last element? Okay, in this case, low is here, electron volt is low here and high at this element is purely because for the last element, okay, as we refer to the periodic table, the last element is far away from the nucleus, okay, from the molecule, from the nucleus of the molecule. So the ionization energy, okay, the atom, this molecule tend to give away, because since it is far away from the nucleus, this one in simplest word we can say lost grip from the attraction of this nucleus, means that it tend to be give away the electron, as compared to those with the first element. They are very close to the nucleus, they are like engaged or bonded to the nucleus, as compared to the one that in the last element. For example, we have here let me check here, where is it? Okay, we have 18, we have the orbital, and then the orbital is far away from the nucleus, then the electron within the orbital tend to escape from the atom. Okay. Okay, on the other hand, noble gas, helium, like neon, argon, have the high ionization potential, because why they are stable is because their orbital in the outer shell is fully occupied. That's why they are in the stable conditions, and since they are in stable conditions, they would require a much higher energy for them to become ionized. Okay, this is what we call noble gas. And those who is without the electron at the higher from the outer shell, the those electron that is not stable in the outer shell, that is tend to escape away from the atom. Okay, this is the periodic table. It's just a recap from the, and this is the, if we can see the ionization potential of some common gas, we can see the ionization energy for the helium is higher than neon, argon, and so on, because these are noble gas. These are the noble gas. They are relatively higher than those in the element 14 and above. Okay, this is just the number, and the graph plot here as per atomic number. Atomic number means that it is bigger and bigger. Atomic number refer to the content of the atom. The bigger it is, the less stable it is, and then hence the ionization is lower. Okay, the ionization progression. Okay, we have learned, we have discussed previously the ionization step, the first step for the gas to become ionized, and then now we are looking how the ionization can progress from what we can classify here. There are three main categories in which ionization by collisions, okay, as I explained before briefly. Photoionization means that the radiations from the radiance, and then the ionization on the surface of electrode. Okay, we going to discuss these three main process of how the ionization can progress. Means that the ionization itself is not really a failure, but the way it progress, that will lead, the total failure of the dielectric materials. Okay, ionization by collisions. You can read by yourself, and to summarize this, I will just explain in the simplest analogy. Okay, by collisions, okay, interchange, say we have two ball or two atom or two molecules, they collide to each other, and the bouncing of this this atom will cause the energy, the kinetic energy from the collision of this one will be transferred to the electron. Okay, the electron will gain more and more energy, so that they will have until after several times they may have enough energy to escape from the atom or molecules. Okay, that is related to elastic and inelastic collisions. Okay, if it is sometimes there will be an inelastic collision in which two electrons collide to each other, and then they are not bouncing into kinetic, they stick together. The total energy from this movement, the kinetic energy, will totally transfer to the electron within the molecules. That will promote the process or the progress of the ionization. Okay, there is a slight difference between elastic and inelastic collisions. Okay. Okay, if we plot the probability of the for the transfer energy versus the electron volt, electron energy. Okay, if you can see, there will be a probability is increased almost linearly to the top, and then after a certain amount of electron energy, the probability will be reduced. Okay, reduced. This is because, for example, okay, we take a simple example at this molecule at this electron energy of 1000 electron energy. The collision between the 1000 this high energy will lead for the collision times between for this to happen is very quick. Okay, imagine you are full energy, and then once it bounce to the wall, obviously it will just have a very short period of time to contact with the other one. Okay, that is the reason why the energy is not being transferred to the molecule, and hence the probability for ionization to happen is lower, because this atom or molecule have a very high energy, so that they don't collide at the adequate time for the transfer energy to occur. Okay, in this case, for example, those within, okay, this is the fact. Okay, if you can see here, increase almost linearly at the first, and gradually with the electron energy up to 150 electron volt. Okay, so means that Okay, the probability will increase linearly up to this 150 electron volt, in which after that it start to lower down. Okay, lower down due to the fact that the electron collision speed at the collision time is decreased, and the probability transfer of electric energy will be reduced. Okay, that is what this is the plot, or the probability versus the probability of ionization versus the electron energy. This is ionization by collisions. Okay, there is also a term that is referred as step ionization in some cases. Okay, in some cases, the collisions of a neutral atom or molecule having less energy, all right, less energy than the ionization energy. Okay, what is happened is actually those with the ionization energy that is less than the energy that is less than ionization energy, the collision between these molecules or electron will collide, and then nothing will happen, and then they start to excited. Okay, imagine a simple, once you bounce, and then the molecule, the electron within the molecule will start to vibrate, a little vibrate, and then you bounce again with another molecule, you start to vibrate again. The multiple bouncing or multiple collisions between the molecule will eventually, after series of collision, will eventually have enough energy to trigger for the ionization. Means that the energy obtained by the molecules is greater than the ionization energy. Means that the electron should be able to escape from the molecule that trigger for the ionization process. Okay, this can happen, and this is normally referred as the step ionization. Okay, the second ionization process that promote to the ionization phenomena is actually the photoionization. Okay, in which the photon having a certain frequency from radiations, obviously they will impart. Okay, photon will impart its energy, which refer to HF, to the uncharged atom. Okay, means that a certain energy from the photon having a certain frequency, if it is greater than a certain is the ionization energy, and then this radiation will cause the atom or the atom or the molecules to become positively or negatively charged. It depends. This is what we call as photoionization, is due to the radiations from the photon. Okay, and last process that we're going to discuss on this topic, progression of ionization, is by ionization in the surface of electrode. Okay, surface of electrode. Okay, electron can appear in the gas. Okay, obviously, in the gas or in the metal or in the solid. Yes, electron can present in any state. Okay. Okay, for the special case for the electrode, for the electron in the electrode. Okay, say for example, electrode normally, electrode in many cases is made of metal or solid, or metal, or what we call it ion materials, which is in general it is a hard in physical state. Okay, once you have two metal and then you knock them together, or you touch them together, you collide them together, that one, the collision of or the what we call it, the impart, the collision between two metal will transfer the certain amount of energy from the action into the electron, in which it will give sufficient energy to the to the molecules to escape from the original state from the atom. Okay, and this kinetic energy will eventually transform from the kinetic energy into the uh, into the energy that will be overcome the ionization, and consequently will result in the ionization process. Okay, sustainable ionization process. Any or more, okay, any or more like any or more ionization process like collisions, photoionization, and surface of electrode. Okay, combination of these three process will constantly promote to the electron to escape from its original atom or molecules. Okay, this process the prolong of this pre-process will eventually, as what we call sustainable ionization, the things that occurred constantly until it come to the breakdown in the gap. Okay, the breakdown. This is what we call is the total failure of the insulations. Okay, the ionization process is just the initiation of the breakdown, and the sustainable ionization process, the combinations of collision of photoionization, and even the surface of electrode may eventually promote to the total breakdown. In this case, the insulator, the dielectric material, who is insulation in properties that prevent the current flow, turn into the conducting state. Okay, the insulator will become into the conducting state, or in other words, we can call it as a breakdown. That will lead to the failure of the insulator. Okay, this can be further explained by two principles of known as Townsend and Streamer's principle in the during the breakdown phenomena.